Q6610-2. What type of stability does the horizontal stabilizer provide during flight? A. Airspeed. B. Longitudinal. C. Lateral. The correct answer is B. The horizontal stabilizer primarily provides longitudinal stability during flight. Longitudinal stability refers to the stability of an aircraft around its lateral pitch axis. It involves the aircraft's ability to maintain a steady pitch attitude and resist changes in pitch caused by external forces or pilot inputs. The horizontal stabilizer, located at the tail of the aircraft, plays a crucial role in maintaining longitudinal stability. It consists of a fixed horizontal surface, often equipped with an elevator, which can be deflected to control the aircraft's pitch. When the aircraft experiences a disturbance that tends to pitch the nose up or down, the horizontal stabilizer generates an opposing force to counteract the disturbance and restore the aircraft to its trimmed or desired pitch attitude. This stabilizing force helps to maintain longitudinal stability by resisting excessive pitch changes and promoting a balanced flight condition. While the horizontal stabilizer contributes to longitudinal stability, it does not directly provide stability around the lateral, roll, axis, or the vertical, yaw, axis. Lateral stability is primarily controlled by the aircraft's wing design, while yaw stability is influenced by factors such as the vertical stabilizer and the placement of the center of gravity. Therefore, in the context of the given question, the horizontal stabilizer's main function is to provide longitudinal stability during flight. 6621-2. When is rotor downwash most prevalent in certain gyroplanes? A. During all-surface movement. B. Immediately prior to touchdown after a steep approach. C. During a vertical takeoff when rotor blades are in a propeller state. The correct answer is C. Rotor downwash is most prevalent in certain gyroplanes during a vertical takeoff when the rotor blades are in a propeller state. During a vertical takeoff, the rotor blades of a gyroplane are positioned to generate a downward airflow to provide lift and maintain the aircraft in the air. This downward airflow, known as rotor downwash, is a result of the rotational motion of the rotor blades and their interaction with the surrounding air. When the gyroplane is in a vertical takeoff, the rotor blades are oriented in a propeller-like manner, similar to a helicopter's rotor in forward flight. As the blades rotate, they create a high-velocity column of air that is directed downward. This downward airflow is necessary to generate the lift required to keep the gyroplane airborne during the vertical takeoff. Therefore, during this specific phase of flight, when the gyroplane is performing a vertical takeoff and the rotor blades are in a propeller state, the rotor downwash is most prevalent. This is the time when the gyroplane experiences the strongest downward airflow generated by the rotor blades. It's important to note that rotor downwash is also present during other flight conditions and maneuvers, but it is particularly significant during a vertical takeoff when the rotor blades are operating in a propeller-like manner. 6700-2. Low-speed blade flap on a gyroplane is a result of A. Taxiing too fast. B. Rotor blade pitch set too high. C. The rotor blades being too heavy. The correct answer is A. Low-speed blade flap on a gyroplane is a result of taxiing too fast. Low-speed blade flap refers to the excessive flapping motion of the rotor blades that occurs at low speeds, typically during taxiing or ground operations. This phenomenon is primarily caused by the gyroplane taxiing at a speed that is higher than what is recommended for safe ground operations. When a gyroplane taxis too fast, the relative wind over the rotor blades increases, leading to an increase in lift and centrifugal force acting on the blades. The increased lift causes the blades to flap upward, while the increased centrifugal force tends to pull the blades outward. This combination of upward and outward motion results in low-speed blade flap. It's important to note that low-speed blade flap is not directly caused by the rotor blade pitch being set too high or the blades being too heavy. While these factors can affect the overall performance and behavior of the rotor system, they are not specifically responsible for low-speed blade flap. In summary, low-speed blade flap on a gyroplane is primarily a result of taxiing too fast, which leads to increased lift and centrifugal force on the rotor blades, causing them to flap upward and outward. 6827-2. How does a negative G maneuver affect a gyroplane's rotor RPM? A. Increases rapidly. B. Remains the same. C. Decreases rapidly. The correct answer is C. During a negative G maneuver, a gyroplane's rotor RPM decreases rapidly. Negative G maneuvers involve a temporary decrease in the apparent weight or gravitational force experienced by the gyroplane. In such maneuvers, the aircraft experiences an upward acceleration, causing the rotor blades to experience a reduction in lift. As a result, the centrifugal force acting on the blades becomes greater than the reduced lift force, leading to a decrease in rotor RPM. When the gyroplane enters a negative G maneuver, the reduction in lift on the rotor blades causes them to slow down. The centrifugal force, which opposes the inward bending of the blades, becomes dominant and causes the rotor RPM to decrease rapidly. It's important to note that during a negative G maneuver, the rotor RPM doesn't remain the same or increase rapidly. The reduction in lift and subsequent decrease in rotor RPM are characteristic of negative G maneuvers in gyroplanes. In summary, a negative G maneuver in a gyroplane results in a rapid decrease in rotor RPM due to the reduction in lift and the dominance of centrifugal force. 6833-2, which may lead to a power pushover in a gyroplane. A. Low speed. B. Rotor force is removed. C. Decreasing power too quickly. The correct answer is B. A power pushover in a gyroplane may occur when the rotor force is removed. A power pushover refers to a sudden and significant nose-down pitching moment experienced by the gyroplane. It can happen during certain flight conditions or maneuvers when the rotor force, which provides the main lifting force, is suddenly removed or significantly reduced. When the rotor force is removed, such as when the engine power is abruptly reduced or the rotor loses effectiveness, the gyroplane's nose tends to pitch downward. This occurs because the lifting force generated by the rotor is no longer counteracting the aircraft's weight and producing a balancing torque. As a result, the aircraft's center of gravity tends to rotate forward, causing a nose-down pitch. It's important to note that low speed or decreasing power too quickly may have an impact on the flight characteristics of a gyroplane, but they may not specifically lead to a power pushover. The critical factor in a power pushover is the sudden removal or reduction of the rotor force. In summary, a power pushover in a gyroplane can occur when the rotor force is removed, causing a sudden nose-down pitching moment. Other factors, such as low speed or rapid power reductions, can affect the aircraft's flight characteristics but may not directly lead to a power pushover.